Today's video is called Writing and Solving Linear Equations, and what we're doing is taking a few of the sections that we've done before and combining them together. Alright, a few sections ago we took English sentences and converted them to working equations or working expressions, and then another section we solved those equations. So basically we're going to take those and put them together. Alright, and you notice I have my little list over here that I mentioned before about if you go down this list when you're solving an equation, it really does help to tell you what to do first. So I've got that over there. We'll keep that over there. And let's dive into exercise number 1. It says one angle is 5 less than 3 times the size of another angle. So the first thing I want to do is I want to define my variable. Like, what is it that I'm looking for? And so I always start with let x, or whatever variable you want to use, but I'm going to use an x. So it says one angle is 5 less than 3 times the size of the other angle. And together they have a sum of 143. So I know I'm going to be adding something. But what are the sizes of each angle? And a lot of times if you look for the question mark, that tells you what you're looking for. So they want the size of each angle, and that is more than one angle. So I'm going to start and just by saying, well, let x equal one angle. And they really do tell me about the other angle that I want. They says the other angle is 5 less than 3 times another angle. So I would write 3 times another angle as 3x. And here's a couple sections ago I mentioned you've got to be careful with less than and less. Alright, and whenever they use the word less than, or the words less than, then that means you're going to be taking whatever comes before those words less than, and you're going to take it away from whatever comes after. So I'm going to take 3 times another angle, or 3x, and I'm going to take away 5. Alright, and I'm just going to say 3x minus 5 is the other angle. Alright, and that is part of the problem. That's defining the variable, so make sure you do that first. Alright, now we want to create an equation. So I'm going to use, really I've used this part. I'm going to just cross that right out. And it says one angle is 5 less than 3 times the size of another. Well, I've got that, and I've got the other angle, and it says together they have a sum. So I'm going to add these two angles together. I'm going to take the one angle, I'm going to put these in parentheses just to separate them so you can see where I'm coming from here. And here's the other. And I just took that from right up here. Here's my two angles, and I'm going to sum them. So I put an addition sign in between, and their sum is 143. So there, just from this statement right here, this sentence right here, that is where I got my equation from. Alright, so now we need to solve it, and first I go over to my list and it says to distribute. Well, I don't have anything to distribute. There's just ones in front of these parentheses, and if this was a minus sign I would have to distribute that -1, but I don't need to if it's just a plus, so I'm just going to drop those parentheses right out. And then I'm going to go to number 2 over here, combine like terms. Well, do I have any like terms on the same side of the equation? And it looks like I do. I have this 1x and I have this plus 3x on the same side of the equation. Remember, the equal sign separates two sides of the equation. So I take 1x and 3x and I get 4x, and everything else just comes right on down the line. Alright, so I combine like terms, and number 3 is to get the x's to one side. Well, I only have one term with an x in it, so I've got that to the right side, and the correct side I should say. And now we need to solve for x. So we've been doing this for a long time. We add 5 to both sides. We did this last year in our Math 7 course, and I need to take 143 plus 5, so I get 148. And now I need to continue solving for x, so this is being multiplied, this 4 times the x, so that means I'm going to do the opposite. I'm going to divide on both sides. And in my head right now I can't do 148 divided by 4, so I just grab the calculator and, whoops, I want 148 divided by 4, and I think, yeah, it comes out nice and even like that. Excellent. So that's a 37. over there. Okay? Now, don't stop there though. Make sure you answer the question, and this is the reason why we define the variables up here, because then we go up here and we say x is 37 degrees. Notice I put a units on there because I'm all done with my equation. I've got to make sure my units are on there. And I want to know what the other angle is. Well, I define the other angle as 3x minus 5. So I want to plug what I got for x into that little expression. And 37 times 3, I can do that one. That's 111 minus 5. 111 minus 5 is 106. And so that means this other angle is 106. So there, right here, I've answered my question by putting in what each of the angles are. Okay, so make sure you go through that process. You define the variable, you write the equation, you solve it, and then you definitely have to go up here and answer the question. So here's number 2, and we're going to do the same thing. We're going to go through that same process, and sometimes if you draw yourself a picture, it may help. You know, given a right triangle, so I'm going to draw myself a right triangle. It doesn't have to be perfect. And I'm going to put that little perpendicular symbol down there. So I've used this, so I could cross that out if I wanted to. Find the size of the angles if one angle is 10 more than 4 times the other angle, and the third angle is the right angle. Alright, well really I can cross this out as well, because I've already labeled that on my diagram. This is the third angle. That's 90 degrees. Alright, what I want to find are these other two angles. Okay, so let's define our variable. Let x equal, well, they told me that one angle is 10 more than 4 times the other. So this is going to be one angle. They didn't tell me anything about that other angle, that second angle. So you always start with the one that you don't know anything about. Now they did tell me that the other angle, okay, so I could say this one is x. This one up here is 10 more than 4 times the other angle. So how would I say 4 times the other angle? Well, 4x, and then 10 more than that, that would be adding 10. So that is the other angle. Okay, so there I've defined my variables. Now I need to write an equation. Well, they don't really tell me what I can add these up to or multiply them, but if you remember back to when we talked about triangles, if I add up the angles of a triangle, they all add up to 180. So I'm going to take x, and I'm going to take 4x plus 10, and I'm going to take 90, and those should all add up to 180. So there's my equation. Alright, now I just go down the list. Is there any distribution to do? Well, I do have parentheses, but these being pluses, I can just drop those parentheses right out. Alright, it's only a 1 in front of the parentheses, so I don't have anything to distribute. And then I want to combine like terms. Well, it looks like I do have some like terms. I have these two right here can combine to give me a 5x, and these two right here can combine to give me a 100. So very quickly this equation boils down to this. Alright, and then I got to get the x's to one side. Well, I already have that. I have the x over here, and there's no x's over there. And now I just need to solve for x. So I take away 100, and I take away 100 from both sides, and these hundreds cancel each other out. So I get 5x equals 80. And then I'm going to divide by 5 on both sides. So x equals whatever 80 divided by 5 is. So I'm going to divide those two, and I get 16. Alright, and so again, don't stop there. Make sure you go up here and answer the question. So this is 16 degrees. That's what I just got for x. And what would 4x minus or plus 10 be if I plug a 16 in for that? Let's see, 4 times 16 is 64, and I add 10, and I get 74 degrees. So there, I answered the question. And here's exercise 3. Now again, I'm going to draw myself a picture because they talk about a pair of alternate interior angles. And if you remember when we talked about parallel lines, I draw myself some parallel lines, and they cut by a transversal. We had alternate interior angles. That would be like this angle and this angle. They were inside the parallel lines and they went back and forth across the transversal. That's why they were called alternate interior angles. Alright? And they describe them as follows. One angle is 14 more than half a number. Okay, so I'm kind of keying in on that. They say a number. Ooh, what is that? I don't know. I don't know what that is. Maybe that's what I'm looking for. Okay? The other angle is 6 less than half a number. Well, are the angles congruent? Okay, so let's define our variable. They talk in both of these about some number. So I'm going to say let x equal a number. And they tell us about each angle. Well, you guys know that when you have two parallel lines cut by a transversal, these alternate interior angles should be the same. Alright, so let's describe each one of these alternate interior angles. One angle is 14 more, so I'm going to be adding 14 more. I'm going to turn over to red here so I can make that a little different. One angle is 14 more than half a number. Well, this is a number. This is my x. This is a number. So I'm going to take half of that number and I'm going to make it 14 more than that, because that's what they said up here, 14 more. So I'm going to add 14. Okay. Well, the other part of this, and I'm going to underline this in green, but I'm going to write it in red because, actually I can underline it in blue. Alright. The other angle is 6 less than half the number. Okay. Well, 6 less than, remember when we use less than, you take this part first, half the number, and then you take this part second. So I take away 6. Alright? So this is going to be, I'm still defining my variables here. This is one angle, and this one is the other angle. Alright, and just I got that from the sentences up here. So they say, are they congruent? Well, if the angles are congruent, that means the two would be equal. Alright, well, let's make an equation that sets them equal and see if it works. So I take the part in red up there, there's one angle, and I set it equal to the part in blue. That's the other angle, and I want to know, are they congruent? Well, let's see what happens. When I distribute, well, there's nothing to distribute. When I combine like terms, well, there's no like terms to combine there. Alright? And then I get all the x's to one side. Oh, there are x's on each side. So let's take away 1/2 x from both sides. Well, they go away there, and they go away there, and I get 14 equals -6. Now, if you remember from the video before, we said if all the x's go away, we have to say to ourselves, well, is this true? Is this a true statement? And that is definitely not a true statement. So that means that no x's will work for this equation. There is no solution to make that work. Alright, so answer your question. Are the angles congruent? No. Since there's no solution that will plug into this equation and make it work, the angles are not congruent. Okay? So each one of these, we followed the same pattern. We defined the variables from the English terms up here. We created an equation, again, from the English statements up here. And then we followed this list that we developed before to solve the equation. And then make sure you answer the question. Whatever they are asking, make sure you give me an answer. Okay? So, hopefully that was good. Hopefully you followed what we were doing. The questions that you do tomorrow will be very similar. So, thanks for watching. and have a good night.